In science, we often emphasize so much on performance and functionality, but we forget to inform our societal stakeholders about the risk and cost. From academia, we always have this idea that if we invent some nice technology, they would just embrace it. Multifunctionality is very difficult to achieve because we just have so limited space in cities. Reuse, recycle, and these strategies, which one is best for which stream, that is still unknown. You should look at what product you recover or you convert food waste into, but also you should look at what you are replacing in society.
That is Wei-Shan Chen, also known as Momo, Assistant Professor in Environmental Technology at Wageningen University in the Netherlands. After completing his studies in materials engineering, Momo pivoted towards the environmental sector to do his part in changing the many linear approaches to managing our resources, closing the loops on carbon and water through innovative technologies, tools, and active stakeholder engagement. He has a keen interest in solving our global food waste crisis through more conscious resource recovery, reduction and recycling, and in creating greener and more livable cities. My name is Peter Marcus Bach, and this is the Grand Challenges Podcast, a show about inspiring individuals who are stepping up to tackle the global challenges that our world is facing in their own unique ways. We reflect on the many out-of-the-box ways our guests have navigated the complexity and intricacies of the environment at the cutting edges of science, engineering, technology, and design. On today's show, Momo and I discuss his different innovative approaches to closing the carbon cycle, from working with microbes and fungi in fuel cells to heating and food waste valorization. We touch upon his journey into urban blue-green infrastructures and rainwater harvesting, and how his active engagement with stakeholders has evolved his perspective on environmental technology and tools to create a more nature-based, sustainable future. Detailed information is provided in the show notes over at petermbach.com/podcast. Thank you for joining us today, and please enjoy the show. Momo, welcome to the show.
Thank you. Thank you for the invitation.
And thank you for inviting me to the Netherlands to come and meet you again after it's been a while. We met a year ago almost. So it's good to reconnect and also this time to combine it with a podcast.
Indeed. Yeah. We should keep it as a tradition.
Yeah, definitely.
Every summer we meet. Yeah.
Hey, that'll be cool. I mean, I enjoy coming to the Netherlands every now and then, seeing what I've missed out and enjoying the stroopwafel. Especially.
Wow, they are more nice Dutch food, huh?
No, definitely. And with you and now with Martijn in the Netherlands as well, I think there's even more reasons to come and visit. Yeah. But one thing that's always bothered me, and I'm always very curious when I hear this. So, you go by the name of Wei-Shan Chen, but people call you Momo.
Yes.
What's the background there?
Everyone is curious about this.
Yeah.
And first reason that in Taiwan it's very common that you give your baby a nickname and it's easy to call out. And then so Momo has come to me with that reason. But also, my parents call me Momo or my friends because then I was already very strong. Like I look like a strong baby. I had a lot of hair and then I have a lot of muscle. Like my family looks like some people say small potato, but some people say it looks like a wild ox.
Okay.
So then Momo is kind of the sound they make. So a cow mix.
Oh, interesting.
So Momo is the sound cow makes, and then that's how they come up with this name.
Interesting.
They stay with me already for almost whole my life. So
okay.
Yeah.
Oh, fascinating. I guess, you always have this nickname. I remember whenever I meet someone from Taiwan or from China, they introduce themselves, but then they say, but you can call me this. And I'm thinking, how do we even go from one name to the other? But it's fascinating to see how people come up with these nicknames.
Yeah.
But I suppose Wei-Shan Chen, you have characters, they often stand for something. There's usually a symbolism behind it.
Yeah, there is. So for example, this Shan means a very big type of tree.
Okay.
And then my family are all very short. The max we grow is 160 centimeters. So they want me to break the record. And unfortunately, I did not.
Oh.
So, but they put this name. So they expect me to grow taller.
Oh,
than
okay.
That. Yeah, so.
But hey, you got the name of strength as a nickname. So I guess there's something else there. And you took it quite seriously because you were telling me that you also used to play rugby or you still play rugby. At least you like rugby.
I love rugby. I love playing it. I love watching it. I used to play a lot in Taiwan.
Okay.
In my bachelor study. It's quite unique. In Taiwan, there's only one city they play it. And that's the city I went for my bachelor study.
Interesting.
Yeah. And then when I came here, I play also rugby for a few times and I stopped because these Dutch people are really huge, full of power, and then I'm too small.
But I thought if you're short, then you have an advantage because you can go in between all the players.
Yeah, but they are also fast.
I guess that is something you have to always look out for. I remember I used to have a housemate who played rugby, and every time they come back from training, you'd see them like nursing their leg with ice pack, and it's a pretty tough sport.
Yeah, it's very tough. Indeed.
So, but hey, living up to the name of, I guess, a bull, powerful bull.
Yeah.
So we're in the Netherlands, and you're in the fields of, if I had to sum it up, circularity, really trying to close the cycles that our natural world is so good at. But you actually started in Taiwan with your studies, and you actually studied materials engineering rather than the more environmental side. Well, what's sort of the motivation there, or the reasons to go and study engineering in the first place? We've had many stories on previous episodes where my guest was either very good at maths or, had a fascination for everything about engineering or how things work. What's your story?
I think in Taiwan, half of the people choose something related to semiconductors to study. And then so it's either electrical engineering, material science, chemical engineering, but they all end up in this famous Taiwanese company working on semiconductors.
Interesting.
And so there is no particular reason, but I just follow the crowd to do that. Yeah.
I guess it makes sense. There's a certain industrial culture there.
Indeed.
Yeah.
Yeah.
But you went from materials engineering, I guess, maybe wanting to make the next semiconductor, to environmental engineering, where you moved from Taiwan all the way to the Netherlands, in Wageningen in particular. What spurred that move, and also change of discipline from materials all of a sudden to the environment?
Yeah, so I was working as an engineer after I graduated from my bachelor, and it's really in a factory where we prepare materials for semiconductors, for hard drive, for LCD screens. And I did enjoy the work, but I also don't see myself doing that for the whole life.
Yeah. And
I see a lot of pollutions from this factory, from the whole production. And I wanted to do something for the environment. Yeah, and back then I was also a bit naive. I thought if I want to do something for the environment, then I have to do environmental science.
Okay.
If now I reflect, actually, there are so many different disciplines and fields. Actually, you can contribute to the environment. But nevertheless, I decided to pursue this study, and then I had a chance to apply for a scholarship or try something abroad. I wanted to try it. And funny enough, I applied for so many different universities and different scholarships, and I could get scholarship for continuing my material engineering study.
Okay.
But for environmental study, none of them accept me. Even I would pay it myself, except for Wageningen.
Okay.
That's the only university say, you don't have the right background, but we need to try. So
nice.
That was a surprise. So I tried so many places. My bachelor study, I did quite okay, but I was rejected by all the environmental science programs.
Yeah, it's always something that puzzles me, because, you study one thing, but if you want to pivot and you want to try something else, what's the chances of getting in? I think your story is one of hope, where you know that if you need to pivot and you have to change your discipline, it's always possible. And there'll be an institute that's willing to try. And I find we need more of that, because, when you study engineering, it's not really necessarily just the materials that you study, pun intended, but it's the way of thinking.
Indeed.
And they should have thought that too. When you go through an engineering education, what you come out with should allow you to then apply that knowledge and, that thinking to gain new kinds of knowledge elsewhere in a different engineering field, for example.
Yeah.
Or in business even.
Yeah, indeed. That's very true. Yeah. I also think a lot of critical thinking, a lot of training I learned in my bachelor actually applies also during my master, my PhD. So, I fully agree with this. Yeah.
No, definitely.
Yeah.
Or at the very least, semiconductors for computational simulations, who knows?
Yeah.
But okay. And so you came to Wageningen. And you began your career in the environmental sector. And so the other question is circularity. I guess you can think of circularity as, wanting to go back to how nature does things, trying to mimic that, because often that comes with better outcomes as well. But you actually focused a lot on carbon, even though now you are equally involved in carbon cycles, but also water cycles. And we'll definitely get into those topics very shortly. But why go for that in the first place?
That's also a funny story. So I actually, during my bachelor, I failed a subject. That's almost the only subject I failed, and that was organic chemistry.
Oh, no.
And I thought in my life I wouldn't touch it anymore. But then I came to Wageningen, and then I did my master there. And I was offered a thesis topic actually on this, the recovery of organic materials from food waste. I found it super fascinating. So then I couldn't reject. So I started on that topic again. And also what is nice is that in the topic, I was allowed to explore the combination of material science, but also like environmental science. So I have done some life cycle assessment study during my bachelor. And then I could apply those skills also in that thesis topic. So it's nice. So the topic is about material recovery or chemical recovery, but also skills or methodology wise, I could use both my chemistry knowledge and learn something about microbiology, but also apply life cycle assessment together. So I couldn't say no.
It's a luxury situation.
Indeed. So then I decided to pick up organic chemistry and work with that. And even I learned microbiology. I never learned microbiology in my life.
Yeah.
So, that's how I start learning about microbiology.
Okay.
Yeah.
I guess revisiting things that didn't go so well in the past was also a way of closure.
Yeah.
I guess a way of, life will not forget that happened and you're better off just confronting it head on.
Indeed. That's the lesson I learned. If I fail something or if I'm not good at something, then I should overcome that or should confront with that.
Yeah. I remember doing organic chemistry in high school. It was sort of the last part of chemistry, call it the grand finale. And I'm like, okay, I think it put me off chemistry for good. We do cover the topic a bit and my sort of dislike for it, or at least aversion to it on episode 45, listeners. I think this is one of these next emerging themes on the podcast, which seems to come back to haunt me every episode. But nevertheless, so circularity or circular economy, your work is really framed around the two big fields and bringing circular thinking into that, carbon and water.
Yeah.
And your master's thesis, which you finished in 2012, and then the PhD after that, which you finished in 2017, sort of defines a lot of what you do now in the carbon side of it. And that's something I'd like to maybe start with before we go on to more familiar territory, which at least I feel more comfortable in, which is the water side.
Yeah.
But how do I characterize it? I can say you looked at many different carbon sources, you could say, potential areas where we can recover the carbon, we can use it in a more sustainable way. On the one hand, plant microbial fuel cells. Tell me a bit about how do they work? Where do we get these materials from? What are they all about?
Yeah, so this microbial fuel cell, initially they were developed for energy purpose. So we could harvest energy from nature cycles. So for example, the technology I work on is called plant microbial fuel cell, PMFC. And the idea is that plants, they actually do a lot of photosynthesis. And they synthesize a lot of glucose or sugars for themselves, but they don't use all of that. So they excrete through their roots into the soil a lot of these sugars and to enrich the microbial community within the soil. So they get food to eat. And then when these bacteria in the soil, when they consume these sugars, they release also energy in the form of electrons. So what we did actually in Wageningen is then they design electrodes to harvest this electricity.
Interesting.
So in principle, you can get electricity from bottom of a tree or from a grassland or from wetlands.
Or your houseplant.
Your houseplant also, they have a small cute pot. Now, it's actually, there's a spin-off company called Plan E. They are actually producing these for education purpose, but they are also using this electricity. It's not a lot you can produce.
I was about to ask that, yeah.
Yeah. And the voltage is also not very high. It's usually about 1 volt because it's biological process. So they don't want to play around with very high voltage. In nature, then it's not good for the microorganisms. But then this is enough to actually drive some sensors. So then it's actually a natural way of sensing the soil condition.
Interesting.
So they're actually developing this product now.
I was always wondering because I remember studying some of these things in biology, or I think I've read about it as well in the past. But I always remember that the electrical voltage or current that you can generate is actually not that significant. But it seems like it can still power a few kind of devices, like the sensors. I think that's a very practical thing because oftentimes when you install sensors, part of the problem is finding a good power source for them. So low power sensors, hey, why not? Right?
Yeah, indeed. And then, they also harvest energy from local soil. So you don't have to, for cities nowadays, we are also thinking about using these sensors to sense the soil moisture in the urban green. And then you don't want to have cables running around through every urban green space.
Ideally not, no.
No, indeed. Yeah. So this is a beautiful thing that you can try. We haven't done that yet.
Okay.
That's still in our vision to do that. Yeah.
But you've been looking at how they can be then integrated into green facades or green roofs in particular, because, once we have them there, especially the sensors, you can use that to monitor environmental quality within those regions.
Indeed. And also, especially for the upcoming climate change, especially a drought, then you would want to know soil moisture or maybe the plant health a bit better.
Yeah, I'm thinking of those plant pots you mentioned, the innovative ones. They have all these, these smiley face displays. I guess they're low-powered sensors and could be powered off the plant itself or the plant roots.
Yeah, indeed. Yeah.
And so that's the one side of carbon and carbon recycling or carbon cycling.
Yeah.
Another one you've looked at is reducing fossil fuel use. I think very much the subject of your PhD as well. And I came across a term which I thought was quite interesting, but maybe you can explain it to me. I know it's related to this in some form, but what is microbial chain elongation?
Okay, well, this is a difficult question. So chain elongation is kind of, in a chemical engineering background, is how you connect or build up carbon chains. In principle, you can say the longer the carbon chain, then the more energy is stored in these chemicals, but also the more applications you can use.
Interesting.
In the commodities.
Yep.
Yeah, like we use a lot of chemicals in our commodities. And then the difficulty is always to build up this long chain. And that's why we use a lot of fossil resources.
Yep.
Actually, nowadays, if you look at fossil resources, a lot of them go to the energy application.
Yep.
But also substantial amount of them are actually used for our commodity, like plastic and like also a lot of shampoo and detergents. They are rely on fossil resources.
Yep.
So the idea is like, can we use microorganisms to build these carbon chains from very small carbon molecules. And then these small things are easy to find in waste. Yeah, but how to build them to a longer chain, that's the challenge. And that's what I did in my PhD, following a lot of nice research we have done in our group.
Yeah. And I guess once you have these longer carbon chains and the energy stored, releasing them for various processes that you would otherwise need fossil fuels for or any other kind of power or energy for, I think would be very, very practical.
Yeah, that is very true. Yeah.
So, I learned something new about the carbon. As I said, shying away from organic chemistry, and that's very much carbon-centric. But that and the plant microbial fuel cells were a lot of the early work, but you've since also looked at other sources of carbon, particularly in waste, because it's really about trying to cycle that back into the system for a secondary use or a new kind of benefit. You looked at wood recycling. Tell me a bit about what the use cases are for that.
For wood, actually, we start with how do we get heat from wood to solve the energy crisis we have in Europe. If you look at energy consumption, actually a lot of things goes into heating up the houses. And then we use natural gas. At least in the Netherlands, we use a lot of natural gas for this at this moment. We do want to replace it with a more sustainable alternatives. And wood is one of them because you can grow them in a natural land. There's also a lot of wood byproduct or residues like sawdust. In practice, many people already like burn wood in a stove, but then it's create a lot of air pollutants. And our professor thought of another way, that is to use fungi and bacteria together. They can degrade wood and they do aerobic process, which means they also uptake oxygen like we as human. And because of that, they produce also heat. They release heat. And then this is better than, in principle, this can be potentially better than burning wood. For a few reasons. One is that you release the heat slowly and in the more mild temperature. So this temperature is around 40 to 60 degrees.
Okay.
Which actually is close to the temperature we needed for spatial heating.
Interesting.
Yeah, because if you burn wood, then it's a few hundred degrees.
True.
And then you have to try to lower it down and it releases in a very short time. And you have to find a way to store it, etc. But then if you use microorganisms to convert wood, then it's slow, but the temperature you produce is suitable for spatial heating.
That's actually very interesting because you never think about it. But yeah, the degradation process often produces heat.
Indeed.
And I guess you're finding a way to harvest that and use that. And sometimes it's, as you've just explained, it comes at a rate that is actually ideal for what we want. I mean, heating your house, you can burn wood on a fireplace. But ultimately, yes, as you said, you have to kind of store that heat, or sometimes you have to take some of the wood away or put more wood on because it's not warm enough.
No.
I guess the regulation of it is very difficult.
Yeah, and then you burn wood on daily basis if you would do that. But then for this like a microbial wood oxidation, we assume that we can build a reactor and it runs for the whole winter. And afterwards, a lot of these pollutants, they are actually not released, but they are enriched in the final product, which is kind of a compost and you can use for agriculture as kind of an amendment for the soil organic matter. And your soil become more healthy and also more resilient towards climate conditions.
Yeah. And I guess that's sort of one of the ultimate ideal situations, which is to restore the organic carbon within the soil, right? Because in a way, you've also reported a lot of the reason for doing this is to try and enrich the soil. We're seeing a lot of organic carbon loss, or the naturally occurring organic carbon in the soils are declining worldwide, which I guess impacts the quality of the food. It impacts the nutrients it can uptake, a lot of the functions that we tend to forget. We think, we can put soil and just plant something and eat it and it'll be just as nutritious. But I guess there's a lot more that goes into it.
Indeed. Yeah. There's a big crisis now, actually, the soil fertility and soil health. That's something we have overlooked in the past. So the soil health and also soil fertility. When we intensify our agricultural activities, when we engineer the urban soil, we didn't think of that you need to add a lot of organic materials or organic matter in the soil to enrich the biodiversity in there, but also to improve their water retention capacity, etc. So indeed, every process now we do, there's a residue or pollutants, but we try to make sure we minimize that, but then produce something that we can put back into soil.
And so we've covered, the fuel cells, we've covered the wood, but I guess one other big aspect that you've been very involved in is the food production and sustainable food production, hence why we're sort of gradually progressing towards the soil. And we've covered the topic of agriculture a few times on the show, probably most distinctly in episode 10, which has been a while ago. But plant protection products, fertilizers and pesticides, we often put these chemicals or these additives into the soil for the plants themselves to enrich them. But we often forget about the soil itself, which also serves that incredibly important function.
Yeah, that is very true.
I guess just to put food waste, which is really what this circularity is about and what we can do with food waste into perspective. It's one thing growing the food, but then ultimately, it goes to consumption and then a lot of it gets wasted. The UN Environment Programme actually put out a report in 2024 and they gave some very eye-opening stats of food waste. Food waste amounts to about $1 trillion a year, accounts for about 8 to 10% of greenhouse gas emissions. And if you try to make it an equivalent in terms of agricultural land, I'm trying to get my head around that. They say it's about 30% of the world's agricultural land. The food that comes from there, I believe, is wasted. Maybe to put it into better values for people to understand, I think we waste about 132 kilograms per capita per year. This was a 2022 stats. That's about 1 billion tons, which is crazy. And 2/3 of that coming from households.
It's very true. And you are now talking about food waste. Right? There's also another term, it's called food loss.
Food loss. Okay.
Yeah, so waste is what happened in the end of the food value chain.
If I don't want to eat my peas because I don't like peas or carrots.
Yeah, that's one example. And the other thing is that, so in the supermarket or in the farmer's market, if things are not purchased in time, and then they are expired. And
that is food loss.
That is still food waste.
That's still food waste.
And then you have food loss that is more in the upper value chain. So during the harvesting, during the transportation, during the processing, there's also still a lot of side streams and they don't all get used. So these are food loss and waste. And the figure you just mentioned is only the food waste. So if you also consider food loss, there's much more.
Oh my God.
We are wasting.
You're just putting that into perspective. So it's things like if the tomato is not round enough, then it gets discarded.
And those are like quality control already at the farm level.
Before it even ends up for sale.
Yeah, and it
actually reminds me of a campaign that was, I think, in Switzerland at some point. Maybe it's everywhere else. You can sort of subscribe to it. But you could order a box of ugly vegetables.
Indeed.
That was one way to reduce the food loss. And they would send you a box and you see the weirdest looking carrots, the weirdest looking eggplants, the least round tomatoes. So it's quite creative, I must say. And I guess, it tastes the same in the end. intent, but it's the human perception that of what constitutes a carrot. What should a tomato look like? And I think that's it's crazy when you think about that, how much thought goes into the psychological aspect of food production.
Yeah, true. Now, those are beautiful examples that if you get to consume them, I think that's the best you can do.
Yeah.
And in case you cannot, that's the research we are doing now. So first we are identifying where these food loss and waste are generated, how much of them, and we are even doing a lot of campaign to understand quality, but also composition of them. We are now already building a model to calculate how much benefit you can get from converting them to different resources. Yeah, so examples including chemicals, that's our specialty, but also many of them can become feed or many of them can become fertilizer or compost. And then we want to use scientific knowledge and evidence to show what you should do for which stream to maximize their benefit. But in the end of the day, the best is we don't waste.
Yeah, I guess that's, if you think about it, there's the famous hierarchy. They call it the food waste valorization hierarchy.
Yeah.
And I think, listeners, you might have heard of this hierarchy used in a very different way, but there's the famous words, reduce, reuse, recycle.
Yeah.
I guess to go into detail, you have recover and recycle. So it could be either. I know certainly in the wastewater sector, we talk about resource recovery. So recovering the nutrients from the wastewater. And then at the very bottom of the hierarchy is disposal. So you want to try and minimize the amount of disposal. And that's often either incineration or landfilling. I guess you want to avoid incineration because that in itself also brings a lot of problems, air pollution and many other aspects.
Yeah.
But as you said, we kind of have to be aware of what we're doing and how we're doing it at every point in the hierarchy and try to prioritize the prevention in the first place.
Yeah, indeed. This hierarchy is just kind of a conceptual guidance. Many hierarchy, actually, you can, I think, depends on the context, also depends on which stream. Actually, this hierarchy order will change. So we have to be aware of this. There are already quite some scientific research indicating that the current hierarchy may not be the most beneficial in terms of environmental sustainability, but also in terms of economic performance. Yeah, so if you don't waste, that's of course very nice. But once you waste, then which are strategy, like you said, like reuse, recycle, and these strategies, which one is best for which stream, that is still unknown.
And so you've been looking at that, I guess, at the higher level, understanding these strategies. I think you've looked at the case of Australia, the Netherlands, and China. What were some of the contrasts there? Yeah,
so for example, Australia is really an exporting country. And then that paper, we actually discuss the loss of organic materials in the food waste management. So for example, in Australia, if you export so much food and biomass, but then these organic materials or the residue doesn't come back as a soil amendment in Australia, then we are depleting the Australian soil.
Interesting,
so as a net food or organic carbon exporting country, you have to pay attention to that soil quality. On the other hand, you also have country that importing a lot but doesn't produce anything. A good example is like Singapore. I think most of food are produced somewhere else and not in Singapore itself, but all the food waste are ending up in Singapore. Then you have so much carbon you have to treat.
Interesting.
And the only way you would choose, it's also a small country without so much land, then you would actually choose to incinerate it, which is the worst way to treat it.
Because you're releasing it back into the atmosphere.
Yeah.
We kind of don't want that.
No, we don't want it. Yeah. So then the best way is actually then you make a nice product, you use it, or with a residue, you try to make a nice compost or fertilizer with some nutrient that is still left over in there, and you bring back to where food is produced. And that's why we did such study to showcase for net food exporting country or net importing country or a balanced one, what is the consequence on the soil and also food waste management.
Then there's China and the Netherlands. How do they sort of compare to Singapore and Australia?
I think China is kind of a bit balanced in this case. But a lot of management practice in China are actually not recycling or recovering all this carbon and nutrients. And that has something to do with food waste management and practice. In the Netherlands, we actually have been amending our soil with a lot of manure. So then actually the organic carbon there is relatively enriched, but still we calculate a gap that if you want to restore the soil organic carbon level back to, let's say, 100 and 200 years ago, before all this intensified agriculture take place, we need a lot of food waste to do that. depends on where you want to end up. Then we do such calculation.
Yeah.
But then in general, all the message is that if you want to restore to 100 or 200 years ago, then we are really far from that.
Yeah. And we need to be more active about, I guess, managing the cycles. It's a global cycle.
Yeah.
And it's actually crazy when you think about it. Yeah, if Australia is exporting the food waste for processing offshore and it's not coming back, you're essentially losing biomass.
Yeah,
valuable biomass that could, enrich the soils and really create better outcomes.
Yeah, true.
But apart from that, I guess you've been looking into not just prevention and the distribution, but also conversion of food waste. So you've mentioned some examples again. So you've got the animal feed as one option, but then also agricultural applications. I mean, given the kinds of foods that we encounter, also the highly processed foods, is there anything that we need to be aware of in the conversion of these wastes into valuable products?
Well, that's a very good question, because that's also why people start to rethink about this hierarchy. Because what we notice, and I think in general, some scientists notice this also, is that if we look at this from environmental sustainability point of view, you should look at what product you recover or you convert food waste into, but also you should look at what you are replacing in society. And there are two questions there. So one is, are you really replacing something? Are you really substituting something? And it's not only a technology study. It's also like the society accept that. Do they really use it on a daily basis? Yeah, that's one. And the other thing is like how much environmental impact you avoid by replacing it. So for example, if we produce chemicals from food waste, and then that get to really replace a very dirty product. By dirty, I mean like intensive in carbon footprint.
Then you fossil fuel based, things like that.
Yeah, indeed. Then you actually avoid a lot of these. That's how we should look at the hierarchy. Not only think about what we recover or what we recycle, but also what we are really replacing. That part actually plays a very big role.
But I guess also part of the challenge of this, unlike water, which we'll get into very shortly, when I think food waste, I mean, it's going to depend on people's diets, people's preferences. I mean, I like myself a good sausage on the barbecue, but I know that is highly processed meat compared to, say, a nice salad. So the decomposition of that, I mean, I don't know if it's related to also the calorific burn rates of food, but I'm sure there's a relationship there. I have no clue about the food. I just enjoy my food. I like eating it, not studying it. Although I should go into it. It's a very fascinating topic, just reading into it and talking to you about it. But I digress. But people's diets and the kind of food that ends up in the waste. A organic salady kind of mixture is going to be different to process than, say, 3 chocolate bars uneaten and a steak and I don't know. And how do you deal with that?
That's a difficult question. So that's what I mentioned about the food loss and waste. So food loss usually has more homogeneous composition. And we can better predict what to do with that.
Hence the distinction. Which is quite important here.
It's very important there. And they are also available in larger quantity and more homogeneous composition. While food waste is so diverse in every city because of this diet choice, because of the collection scheme, etc. For that, you are right. It's super difficult to decide what process to do for that. When you only want to dump them, then you do landfill, you do incineration, then you actually don't care about the composition. But if you want to do recovery of things from there, you do have to start thinking about the composition. And that's also what we are doing now. So for example, I have this PhD student from Nigeria. Then she really collects food waste data from door to door.
Oh, wow.
She started already, I think, 4 or 5 years ago. We designed this big grid container with a lot of grid on it.
Okay.
So, and then the residents or the restaurant owners or the shop owners, they just dump their food waste on that grid. They spray it out. We make a photo.
Oh, wow.
And then we also then kind of annotate which food is that. And then we design kind of a composition database so they can convert all these into a kind of composition table we need to design the technology in the end.
Oh, wow.
And somewhere in between, we also try to use machine learning to automate this process. But it's so difficult because of 2 reasons. One is when they make photos, they didn't really do it from the same height, same angle. And we didn't have enough knowledge that we have to do that.
Sometimes data quality can be a very challenging aspect.
Yeah, indeed. And the second reason is that there are always some foods you never saw before.
Yeah.
So
that is true.
So then that was difficult. Otherwise, it's actually a really nice idea. If you could do this, if we could really design such machine learning and automate the whole process. And then every citizen just has to take a photo of their food waste and upload. We can already estimate the quantity, composition, and then we can expect what we collect tomorrow.
Such a fascinating way of collecting data. I'm very intrigued by that.
Yeah, didn't work, by the way.
It didn't work. Oh my God.
But we hope this will work one day. But also, we have to see how valuable is this. Because there's another difficulty in this is that once you have some raw meat in there, then there's some safety issues. Then you cannot really use that for many applications.
It's interesting to delve into the research around food and food waste in this particular sense. And that's been also an ongoing project you've been doing as part of also the work that you did in the Amsterdam Institute for Advanced Metropolitan Solutions.
Yes.
You actually joined that institute to do your postdoc after you finished your PhD, and you're still part of it, actually leading projects within it. And so one project in particular, I guess, that we can talk about here in regards to food waste is Bin to Bean. You called it Bin to Bean.
Yeah, AMS. So in short, this is called AMS Institute. That's a EU project they acquired. And the idea is that we want to design a whole new way of collecting food waste. So nowadays, you have a bag, you collect food waste.
Yeah.
And then if it's not a biodegradable bag, then you have to throw that food waste into the residue.
Yeah.
And it's get burned or get incinerated. And then if you are lucky, if you have kind of organic bin, and then you can take a bioplastic bag and then wrap it, and then you throw it into the organic bin and you get collected. And if the quality is okay, you can make compost out of it. But now we are thinking actually for all the new buildings in Amsterdam, we want to try if we can use a kitchen sink grinder.
Okay.
And it has been used in several countries, like in Australia. I think it's widely used.
Yeah, I've seen these grinders. Actually, the first time I saw it, I was completely scared. I was like, what is that? Because they can be quite loud.
Yeah. They are very loud and very energy intensive.
Yeah. I guess you got the microbes for that. Hopefully they can generate enough energy, or maybe the plants.
Yeah, but we are actually thinking so nowadays, if you have this kitchen sink grinder and then they are actually the sewer or the grounded food waste, they join the sewage system.
Okay.
Yeah, but it's actually a burden for the wastewater treatment plants. Yeah. So we are thinking more a decentralized recovery. So for example, you have a building of a few hundred people and they all use kitchen sink grinder, and then it's end up in the basement. And then you can do dewatering of that stream. But the rest, we are thinking about a few interesting applications. One of them is to make this PHA, that is a new type of bioplastic, polyhydroxyalkanate. There's a lot of research around it already. That's one application. But the other one, we are thinking to use this stream to feed insects. And then you recover feed materials if the food quality is okay. But then the whole thing is to design a new collection system. And this is actually what I learned during this postdoc. That was an interesting postdoc because my boss offered me 2 years and say, no need to publish, but you have to talk to all the urban stakeholders about how our new fancy biotechnology will really be used in cities and what are the barriers, like what we have to overcome. And then I really talked to so many of them on a daily basis. I was going to Amsterdam 2-3 days a week and talk to different people, to architects, to citizens, to housing companies. And I learned so much from that. Like what are the obstacles? What are the barriers? Why they are not embracing this technology? Because from academia, we always have this idea that if we invent some nice technology, they would just embrace it.
True.
But in cities, in industry, this may be the case.
Maybe, but reality then comes to hit you.
Cities, indeed. So that was valuable that I learned so much, and then also learned how to think along with them. And that really shaped my current career.
And so that's definitely a very big highlight, and trying to change the way we think about food waste and I guess working with it. And it all starts with the separation and with the reduction of it.
Yeah.
Everything else from there is, I guess, knowledge gained. So let's shift over to water. So I guess a bit simpler than food waste because it's not as diverse. H2O, chemical, simple, very nice. But you've also been very active in the blue-green infrastructure space, hence why we met and have been working together for almost 2 years now, I think.
Yeah.
Collaborations on joint projects. And so how would you characterize your work there other than the circularity? What is your mission there?
Yeah, so that's a very good question. I explore this line because also in the same postdoc period, when I talk to all these urban stakeholders, they all mention this urban blue-green as a big thing they want to support, they want to do. But then there's also a lot of barriers in that.
True.
So that's also drew my attention. And also, as we already discussed, in many cases, if you talk about food waste, there's also a lot of water there. So in the end, we also have to deal with a lot of water. So that's caught my attention. And then we thought, okay, then we try it out. We apply a project, we got it. Mainly because we had these 2 years of experience with different stakeholders. And they really say, oh, there are so many nice scientific tools out there, but we actually don't know how we can use it. And I was thinking, then maybe we should, because those are really nice scientific outputs, including yours. Yeah. But then as a municipality, how they would use it, it's not so clear. So then that's become my mission. How do I build a bridge to there? And the other way around, actually, that's what I'm doing now, is to learn so much from the modeling and assessment of these nature-based solutions or urban blue-green infrastructure. And how do I translate that to carbon story?
Interesting.
Because in the carbon field, it's not so developed. All these assessment methods, in my opinion, is behind the development in the water sector.
Yeah.
In water, is so many nice concept methods are around, like your urban bits model, but also these dynamic adaptive policy pathways. Those are things you don't see in the world of carbon. And I'm learning a lot from this field and then translate back to the food story.
You mentioned 2 strong keywords, urban beats, the model that I developed during my PhD and have since been expanding, trying to automate where we can place different infrastructures for decentralized stormwater management that are blue-green in nature. And then the other keyword you mentioned, dynamic adaptive policy pathways, I guess a way of thinking around how we can advance or transition cities into the future and design policies, I guess, that are adaptive, hence in the name, and robust as well.
Yeah, true. So I was really learning a lot from this field. So actually, although I'm doing a lot of research now in the water field, but I constantly extract components that is useful in the sector of food and commodity, chemicals, and also plastics. Yeah,
I guess it comes back to your fascination for materials and now, of course, organic chemistry, which you so love and have mastery over. But it's funny to see how you're in a field where you begin in carbon and then you want to go into water to learn from it. And it kind of has grown to be equal in size to your carbon research field now as well.
Yeah, indeed. I am quite surprised by this.
Yeah.
To me, it's always like I invest in this research line because the city need it. Also because many students in our group, they are so interested in this BGI and nature-based solutions, but also as a way for me to learn so much nice methodology and learn how this is developed. But then somehow I get more chance to work on this. I become more addicted to this. We can say that. Yeah, this is really a nice world. Yeah. I thought there are so many nice tools, so many nice scientists around. Probably I wouldn't be able to continue on this.
But you've developed your own tool.
Indeed, somehow. Yeah.
So tell me about your tool, BGIS.
The idea comes also from the same postdoc period that we noticed that the city really wants to know exactly which piece of land, what we should do. And they already want to know for the upcoming 30, 40 years. They don't need a 100% accurate answer. They want to know more or less. And the reason is they want to calculate all the risk and costs around it. And that's what I learned. So in science, we often emphasize so much on performance and functionality, but we forget to inform our societal stakeholders about the risk and the cost. And there's also not very good way of estimating it. And that's how we start with this BGIS tool in order to map what are possible interventions to do where and when. And we can really calculate the cost and risk associated with that.
No, indeed. Often costs are then treated by the wayside, rough estimates, because we also have a lot of uncertainties associated with them, risks as well. We try to assess it. I think many people forget that risk is really two components, really the severity and the likelihood of occurrence.
Exactly.
And so that often gets, I guess, a bit neglected.
Yeah, indeed. That's also something I learned from another field. Also, then there's a benefit of jumping between different fields and different disciplines. True, yeah. So there's this infrastructure asset management. That's also can be a field itself.
That's true.
A lot of study around it. And there, the core principle is three things: performance, cost, and risk. And then risk is, like you said, severity, but also probability.
Yeah.
Yeah. And then we start to add this also in this BG's model. Yeah, it's really endorsed by our municipality partners.
No, definitely. And simple approach, I guess, a 3-step spatial process where you first identify priority areas. So areas that need some kind of blue-green infrastructure solution. You actually focus on flooding and heat. So two usual suspects of climate adaptation and also for, I guess, determining livable cities. And then you try to allocate different types of nature-based solutions or blue-green infrastructures. I see what your two preferred terms are. So it's also been an ongoing question on the show. So you try to determine suitable site-specific options, such as green roofs on the buildings or nice little wetland systems or swales. And then ultimately you assess the performance at the end, so that you have that, performance information. And amongst that, you would also have costs because you have the system sized down to the neighborhood level.
Indeed.
But you also know which areas you're reducing the risks of climate change from because you are targeting those first in a style of ranking or prioritization.
Yeah, exactly. Yeah. And then also for the cost, where we learn from our municipality partners is that they wouldn't dedicate cost for only doing nature-based solutions or blue-green infrastructure.
Yep.
They would love to combine it with their asset management plan, which means the maintenance of road, maintenance of sewer system, maintenance of drinking water, where they have to open the ground. And they say, if you can give us a model or a tool that can align the timeline of this. So for example, if we know this street is going to be open in 10 years because of drinking water, maintenance, drinking water pipe maintenance, that's the chance you can add blue-green infrastructure, and then we don't have to pay for the ground opening cost. And that's actually how you can accelerate the implementation of BGIs. And that's also the backbone of BGs, why we develop such tool.
Often a very common thing you see, people try to then find these opportunities where something has to be done to implement the blue-green. But I guess it's being more strategic about it as well, because you want to make sure that it goes into the right place and just doesn't get placed everywhere.
Indeed, we want to move away from this opportunity-based and a bit of randomized urban green planning to a more structured and strategic way.
And I guess keyword multifunctional, flood risk and heat, that's important, but then also, I guess, trying to maximize the benefit. You sort of tested this with stakeholders where you looked at cases where what are the ideal locations if we focus only on flooding and what are the ideal locations if we focus only on heat and sort of the balance between that. How was that sort of received?
We only publish these two indicators we try, but we actually try many more.
Oh, many more. Okay.
Yeah. So we tried also in the same study, we tried also accessibility to green by the citizens.
Yep.
We also tried biodiversity on 3 species. We also tried health. We also tried energy reduction because of urban cooling, but also during the winter, if urban green can provide some functions to reduce the heating cost.
Oh, plenty more to look forward to in future to read.
Yeah, indeed. But then often are done very fast. And we are not so confident in publishing them, to be honest, because they are like nice demonstration. And we learn a lot from that. But we are not so sure if they are scientifically strong and accurate. But from this journey, we already learned that this multifunctionality is very difficult to achieve because we just have so limited space in cities.
Oh, yeah.
Yeah. And in many cases, so for example, we calculate for Breda, this urban heat issue, even with the maximum implementation of urban green, we will not be able to solve it to a level that is safe for all the citizens.
Which is interesting because Breda, south of Netherlands, near the border to Belgium, I guess considered a garden city, as you were telling me earlier today as well.
Yeah.
But they only have not as much cover as you'd expect for it to be a garden city, like green cover.
I think they have relatively high green coverage, but the message I think is that even we do a lot, like we add a lot of green based on the current urban morphology, is not enough to prepare us for the upcoming urban heat and drought issues. Yeah, so for now, in BGs, we don't touch any buildings and gray infrastructure.
Yeah.
in my opinion, if we want to survive, then at a certain point, we may have to think about this.
Create large forests above our cities.
Yeah, for
That can
example, in
buffer
this, to keep us safe.
But the general reception of the tool has been very positive, I guess, because you've tailored it to their needs in the first place. So it's really a tool that you designed together with the stakeholders based on the stakeholders' perceptions and needs. And hence it's being used fairly actively to help guide planning in Amsterdam and Breda, as you mentioned.
Yeah, indeed. We do active planning with Breda and Amsterdam at this moment. Yeah, that's also what we are doing now always. We first check with the stakeholders and understand what they need. We try to stimulate this so-called co-creation process, but from the beginning.
Bringing it early on in the planning process.
Yeah, indeed.
So heat and flooding, that's been sort of published, and we'll definitely put that link to the paper in the show notes so that listeners can read a bit more about it. But you mentioned biodiversity, also yet another crisis we face. And that's something that you've also tried to look at within the BGIS tool and a project known as Multi-Green. Could you tell me a bit about how that sort of fared? You mentioned you worked with 3 species. What kind of elements have you tried to quantify for your stakeholders in terms of biodiversity?
Initially, we want to bring all the relevant indicators for BGIs together. So that was written in the proposal. That's why we call it multi-green. Now we are super ambitious. And then we use BGIS in Breda first as a tryout. And like I said, we did flood mitigation, we did urban heat reduction, we did health, we did biodiversity, and then we did also energy reduction. And we already realized that was
a lot of work.
Yeah, that was a lot of work, and each of them are not so in depth. So then we already know that probably we were too naive.
For every indicator you add, it becomes, it's like adding a whole PhD to the story. I know that story all too well.
Yeah, but the starting point is, again, we start with the needs of the municipality.
True.
And in this case, they told us there are so many issues we have to solve. And then they had a long list of risks.
So it didn't quite help. You still had a lot to deal with.
Yeah, indeed. Yeah, so the list is very long. I think it's like 10, 12. I couldn't remember all the risks.
Oh boy.
Yeah, and then by doing 5, we are already kind of overwhelmed. And then you also have to think about, because we promise in the project, the idea in the project is also like we want to automate the whole blue-green infrastructure allocation. But then if you have one objective or one function, that is not so difficult. If you have 2,
it gets a bit more.
It's getting a bit more complicated. If you have so many, the optimization itself is already challenging. But also you get lost in the result.
That's true.
Yeah. So then that's kind of an issue we are facing now. We haven't solved it yet. We have to see how we can solve that. Yeah, that's about multi-green, how we end up there. We want to expand our tool to cover all the risks municipality want to address. Yeah.
I mean, that's an interesting thing, not just the biodiversity elements, even though they did become a bit more of a focus, because your consortium within Multi-Green, I think, was very specialized in biodiversity. But ultimately, it seems to be a whole laundry list of requests when we go into the real world ultimately.
Yeah, indeed. And for biodiversity, also to answer the question you raised, we use this resistance concept. So if you have a certain land use type, then there's a certain resistance for a certain species. So that's a common way you do in the biodiversity or in assessing the connectivity of biodiversity. So we follow that way, but then we do with the BGIS tool. So at really high spatial resolution. Yeah, that was interesting, but then it was really a lot of work. We spent 8 months only to do 3 representative species.
Yeah.
And then the next question is like, which species do we want to emphasize? Yeah, probably we can do that. Or if we want to do it for many more species, then we have to find another way of modeling to make this fast, but also still tricky. Reliable. Yeah.
Very, very tricky.
Yeah.
I mean, my own forays into biodiversity, I can totally agree. It's been very, very tricky. For listeners who want to know a bit more about some of this methodology as well, we've covered it previously on the show on episode 14 with Janine Bolliger, where we talk a bit more about animal movements and how we can try to understand them better and why it's important for biodiversity in the first place. But water is where you're a bit more comfortable. Okay, carbon is your ultimate comfort there, but water is more comfortable. And you've actually also looked at other aspects such as rainwater harvesting. And Europe's been usually very abundant with water, but I think the recent decade has pretty much showed us that water is not infinite, and there's been drought issues or potential risks of droughts in Europe. And so you've been looking at rainwater harvesting as part of another project that you've been doing called Rain Oasis.
Yeah, indeed. So the project started with a question like, do we really irrigate our urban green or not? That was an interesting discussion we had with the municipality of Amsterdam. And they say, in general, in the Netherlands, in general, we think there's a lot of rain. So we only irrigate the first 1 or 2 years for the newly planted urban green. And afterwards, we expect them to be self-sufficient.
Ooh.
In the past decades, it was true. And there's occasionally a drought, and then some plants die off, then they have to replant. But it's always cheaper than irrigate regularly. But also a big question is also like, we actually don't know when you should irrigate and how much.
Interesting.
Yeah, so then that's kind of a starting point of Rain Oasis, is to understand the irrigation demand and where to get this water. Because municipality of Amsterdam start to notice they have indeed more and more greening space that they have to replant, which become a cost issue. But also, if they don't replant in time, they also notice sometimes the soil health is compromised.
Oh.
And this, I think this is easy to imagine after hearing this complaint. As a scientist, you can imagine then you lose your plants, then the water holding capacity of the soil is also reduced, and then there's a lot of organic materials in soil that was deposited by the urban green, but you start losing them also.
True.
Yeah, if they get dry, they start to oxidize. Yeah, and then all the microorganisms live in there, or biodiversity there is also reduced.
And we've had this discussion about soil organic carbon. That's been a big issue. So in a way, similar avenue.
Yeah, but then the cascading effect is that then as a municipality, you may have to not only replanting the trees or the green, but also replacing the soil, which is a lot of work and disturbance to the city, but also a lot of cost.
So at the end, better to then do the irrigation properly.
At a certain point, yes. That's the focus or the core of the Rain Oasis project, to estimate when this green would be stressed and when should we do irrigation, and also look at how much water we can harvest during the rainy season and store in urban space and then reuse them later on.
And also just to maintain the greenness of the green infrastructure within the city, because then they'll deliver all their other benefits. So
that is very true. So in that project, we discussed with the municipality, and then we come up with 3 levels. One level is to keep soil healthy, and one level is to keep green alive, and the other level is really actively providing all these ecosystem services by green. For example, like cooling down the city. Yeah. And then these 3 levels represent 3 different types of irrigation demands, and we quantify how much water you have to add. We come up with optimization also about when and how often you should irrigate. So then that helps the cities to prepare for the drought.
Very, very fascinating. And so you've got the carbon stream of research, you've got the water stream of research. So where are you heading to next? You're going to add another cycle to your portfolio? Are you going to maintain these 2 at equal levels?
I will maintain these 2 at an equal level. I see them start to merge together, like we talk about this water and soil organic carbon. And then also if you have more urban green, then we tend to have more landscape residue that we can do something nice about. For example, generating heat from this. I think I will maintain these 2. But what I like to do is to add more digitalization elements in both stories.
With your low power sensors.
Yeah, with my low power sensors to sense the city, to build nice data set, for example, advising on the soil and the green condition and know when we would irrigate. But also my dream is to build a more interactive and adaptive digital twin of the city, and to simulate the long-term consequence of every decision we make now, today or tomorrow.
And that's definitely a very nice and noble goal. And I think it's going to be fascinating to see how you get there, especially now that you have both the carbon cycles and the water cycle in your hands, and you can start to put them together.
Yeah, indeed.
Is urban farming on the cards at all?
We explored it. But to be very honest, I personally is not a big fan of aiming at food production from urban agriculture. I think urban agriculture is a very nice thing for many other benefits, like to bring the community together and to green the city. But as a food production, I'm not very certain. In our group, we have done a research to look at the fertilizer dose within the urban farm. And then it's usually much more than optimal.
Okay.
And then when you have rainwater coming, then that means a lot of nutrient leachate.
Oh.
Yeah, so I personally, I'm not a big fan of these. So also we didn't include that option. But of course, I may be wrong.
I guess who knows?
Yeah, who knows?
But I thought, I guess better do something with the food loss and the food waste than trying to generate even more food that you have to then deal with afterwards.
Yeah, indeed.
Yeah. Momo, it's been fascinating going through your story, your twin research pillars, and just generally your journey. But like I do with every guest, I'd love to get into the Q&A questions that I ask everyone so that listeners can get to know even more about you. And so I guess one word that really underpins a lot of, research and the scientific edge is innovation. So in your view, what does the word innovation truly mean? And how has it shaped the way you approach challenges or opportunities in your work?
Wow. That's a very good and also fascinating question. I think innovation, there are two types of innovation. So one is you combine existing knowledge, but you find a new way to use it. That's kind of innovation that we have done a lot, at least in my research team, for all these models. Like we create a lot of models or assessment methodologies. I can say we actually didn't create something new. It's all built on existing knowledge. We learn a lot from existing models. We just transform it in a way that our urban stakeholder can directly use it for their daily job. There's another type of innovation. Is really to create a new way of, let's say, using natural resources. That's more difficult. So one example is this microbial wood oxidation we are doing now. Yeah, we are finding new cultivation conditions that is not in nature.
Interesting.
And to train or to adapt our microorganisms to that condition. So one example is we are using higher level of oxygen that is higher than in the atmosphere.
Oh, wow.
To stimulate the degradation of wood materials by fungi and by bacteria. And we see they are able to degrade more and faster. And this is not in nature. And so this is another type of innovation. It's very similar like genetic modification or augmentation of different microbial communities to treat certain pollutants. And so this is another type of innovation. We try something based on nature, but that is not existing in nature yet.
Interesting.
Yeah, so these are two types of innovations. And I personally like to pursue both. But I'm only a single person with a small group of PhD. So I also have to be careful with my ambitions, like we learned from your degree. So I think nowadays in our team, we focus much more on the first type of innovation, how to integrate existing things, make better use of that to support our daily activity. While the other type of innovation, we are still pursuing it, but with limited capacity.
But it's a nice way of looking at it and how you create the new knowledge. And one is really, I guess, within the field of existing knowledge, combining it together, standing on the shoulder of giants, I guess. Whereas the other one is really being science fiction or making reality out of science fiction. So very, very fascinating. Was there a key moment, book, person, event that completely changed the course of your career or your mindset?
Whoa. If I have to trace back this, I think it's the moment I accept this postdoc offer. So it's really completely a different type of project. I'm used to like lab work with reactors, with microorganisms, and suddenly there's no experiment, not even some modeling exercise or assessment. Just go and talk to urban stakeholders. Yeah, that was I didn't know what I would have. It's more like this is a really interesting challenge. And I thought I also want to use this chance to learn more about society. That's something I always wanted to try. So I took that opportunity. And this is offered by our former professor who is retired now. That's Hubert Reinhardt. Yeah, that's actually kind of a key moment I changed again.
I guess it opened up your mind to how it's really done in practice.
Yeah.
Some of the barriers we experience that are really not technological.
No, indeed. So I learned a lot from that. This may be not new for some people if they have been working in such an environment for a long time. But for me as a material scientist and later on a biotechnologist, this is really new. And I'm happy I could combine these two worlds.
Yeah, I guess your horizons are often very narrow when you're focused on the topic, the scientific and technical topic, until something like this happens.
Yeah, indeed. So to put in a more engineering term, the spatial scale I used to work is always like nanometers.
Yeah.
And later on, I maybe scale up to like millimeters with bacteria and fungi.
Yeah.
But suddenly in my postdoc, I have to work with kilometers. And then, then the first question I ask myself is like, can we do things at millimeter level and still evaluate everything at a kilometer scale? And that's how we come up with BGs.
Very, very different scales, but I guess that's a nice way of putting it.
Yeah. Indeed.
That's true.
Yeah.
And so what tips and strategies can you offer in terms of time management? How do you maintain a balance between your professional and your personal time?
I don't know if I can answer this question because I'm terrible with time management.
And don't worry, that's what all my guests say.
This is a funny story. So I learned this matrix because I'm very bad with time management. So I also did some personal training on this. And then we went through all these different tip and approach that can help me with time management. Mm-hmm. And one thing I like very much is about this matrix. You have things that is urgent and important. You also have things that are urgent but not important, those metrics. And so I did it with my coach. So we start writing down things and place them in the right place. In the end, my coach told me that I don't think this is a skill you need to learn because I can see you can really put the things in the right box very well. The only thing is there are just too many things.
Nah. So reducing.
Yeah. So after 2 days of training, then that's kind of the message we learn. Yeah. I just accept too many and I'm easily triggered by many things. I have curiosity for so many different things and I easily say yes and think I can manage so many things. But if I have to give a tip, that's really a wrong example I'm making.
So it's not about the matrix. It's about saying no to things more.
Indeed. Yeah. And stay focused and sometimes even control your personal curiosity.
Yeah. I guess a little bit of an amusement to me. And the listeners can't see this because we're sitting in a random office at the University of Leiden. But the matrix you're talking about, I believe, is up on the whiteboard right there.
Oh, indeed. Just in front of me.
Just pointing to the back because we walked in and that was the first thing I noticed in the room. And it's called the Eisenhower matrix.
Indeed. Yeah. That's the name.
So two axes, what's urgent, what's not urgent, and what is important, what is not important.
Yeah, indeed. Exactly. Oh, it's really funny. It's just there. I didn't see it.
Serendipity, as they say.
Yeah. But my matrix was, 10 times bigger than this one.
Yeah. Okay.
Yeah.
Because there were 10 times more items in there.
Yeah, indeed. And then that's when my coach say, there's something wrong with this.
So you see, hidden message. It's not about the matrix. It's about saying no to things.
Indeed. Yeah.
Very good tip.
Yeah.
What is your favorite childhood memory?
Wow, that's a difficult one. Well, I start with a more negative one.
Okay.
I grew up in the countryside together with my grandparents. And there's a lot of nature and the neighborhood is not so crowded. So I get to see the sky often.
Yeah.
And then later I moved to Taipei with my parents when I was, I think, 5 years old. And the first thing I noticed is there are so many skyscrapers. If I look into the sky, it looks like a very thin corridor or you have limited access to landscape, let's say. And that's something I feel quite sad about. So that's really a moment I feel like I actually want to live in another place or go back to my grandparents or maybe do something for the city. I don't want to, for example, I don't want my child to look up into the sky, but only see a thin stripe of blue. Yeah. I want them to be able to see a big landscape, etc. So that's kind of a moment that was a bit negative, but that's always been a strong motive for me to improve the city. But a happy moment I had was that, like I said, I grew up with my grandparents and my dad and my uncle. They read a lot of books and they didn't clean up. They just leave it in my grandparents' place. So that's how I spent my childhood. I was reading and reading and reading. Okay. And those are really like all kind of books from textbook to a lot of novels.
Oh, wow.
But also to poems. And then I didn't understand many things, but I just create a fantasy and imagination in my mind. Yeah, that's something I really love. I miss those times that you can read without any instruction or without any boundaries.
Yeah.
I really enjoy it. I often think of those times. I was only 3 or 4 years old, but I learned to read really fast because of those books, and
Wow.
I have enjoyed it a lot. So I'm also doing the same thing now in my home.
Yeah.
We have a big bookshelf in the living room,
Okay.
and we have now almost up to 200 books for my son. Yeah, he can read.
Oh, wow.
And then we also don't give him so much instructions. We help him to read, to understand. We tell him the stories, and he's super happy about it. Like
That's
the
amazing.
first thing he does after he woke up is like, I want a book. Sometimes it's nice. Sometimes when we have to send him to daycare, that has become a big obstacle. Yeah.
But I think it's amazing because nowadays, the new generation, it's more like, I want my iPad
Yeah, indeed. Yeah.
instead of I want my book. So
Yeah, indeed. So we try not to give him iPad so much. We still give him from time to time.
Yeah.
He needs to learn this.
yeah, of course.
But still, I think when you are able to open book, read it, and then there's no time pressure, you can imagine based on the book. I think that's a beautiful moment.
I think so, yeah.
So,
But you said textbooks. So does that mean you were reading about organic chemistry when you
No.
were 3?
no, luckily not. yeah. But it was a lot about medical science because my
Okay. Wow.
my uncle wanted to become a doctor.
Okay.
Yeah. So then
Interesting.
it was interesting to look at all the human bodies and organs.
Well, it would have been more accurate representations of them rather than what you find in a kid's book.
Mm-hmm. Yeah, true.
Thanks for sharing those memories. I think it's very interesting to see the contrast and how both have sort of affected you in generally a very positive way.
Yeah,
And in a way defines who you are now.
very true.
And so what was one of the most challenging situations that you've ever faced in your career to date? And how did you overcome it?
Whoa, that's also a very good question. So I think managing a team, that has been really a big disaster for me.
Disaster? Come
Yeah, because like I said first, I say yes to many things.
on.
I committed to so many things, and I become too busy to spend the quality time with all my PhDs. And sometimes this has a consequence on their progresses. That's one thing. But also on the other hand, I'm learning how to have a proper leadership style for every type of PhD students.
I guess, they're all different. You have to learn their styles.
Yeah, indeed. And that has been a challenge for me. If you have so many projects, so many PhDs, and so many deliverables, sometimes I didn't take enough time to understand each of them and to grow or to co-create a certain supervision style. And that has been an issue. Like it's easy actually for yourself to do something.
Yeah.
Instead of you have to instruct and guide other people to achieve something. Yeah. So that has been the biggest challenge in my life currently. But also, let's say if I look back, it's never difficult for myself to finish my own PhD, to start a postdoc project, etc., to hunt for funding and to network.
Yep.
But then sometimes when you have to guide other people how to do it, then
It's a whole different challenge.
Indeed. Yeah.
Because you don't have as much control. You can only steer it with opinions, with, I guess it's the human dynamics of it.
Yeah, indeed. Yeah, and everyone has different style, but also strength and weakness. And I'm now learning how to maximize each one's strength and minimize their weakness. Yeah.
It'll be interesting to revisit that when we bring you on for part 2 at some point in the future to see how much you've gained from there.
Yeah.
Or how much you've learned from it. And so I guess in relation to that, what advice can you offer to young researchers starting out?
I think the academia is changing rapidly, and I see it will change even faster and more drastically. So, but I think what will not change is that you have to solve a societal issue. That should always be the starting point. So I would say don't forget about it. I see not only in our case, but in many projects around me or many scientists around me, there's always a big success because you wanted to solve something that is really a big issue in reality. Nowadays, I see also many research try to create kind of an illusion on a problem, and then they try to solve that. So I would say stay away from that. We should spend enough time and quality time to understand what needs to be solved. That's one thing that will not change. And the other thing is, I think, learn some programming skills.
Yeah,
Doesn't matter if you do lab work or you do model or you do other type of studies. I think many people may advise differently now with the emergence of AI, but I think programming, very basic skills, that's something I try to urge all my PhDs still to do.
Oh, I think it's an essential skill. Yes, listeners would heard that we've had a discussion of vibe coding on the mini-series, but I can certainly say that no, AI, as good as it is, I think being knowledgeable about programming, whether you use or don't use AI, I think it's still an essential skill.
Yeah, indeed.
I certainly agree with that. I support you on that.
Yeah.
And so as we get close to wrapping up this episode, what would you most like to be remembered for?
Wow. from this podcast, you mean? Or
no,
just in general?
Alive.
It's
the existential question.
Wow, that's I didn't see this coming.
It's in the protocol.
Okay.
Which you didn't read.
I didn't read to the end, I guess. This is very difficult. My own vision. So what I want to be remembered, at least from my scientific career, is that we are able to really reshape the city to a level that we actually can tackle global issues like climate change, but also their consequence at the local level, but still fulfill everyone's preference in terms of aesthetic value, in terms of comfort. So how do you bring this different level of preference or necessity together? So there's this concept of cone of future, and there's a future that is possible, there's a future that is plausible, but there's also future that is preferred. And then actually we want to have a preferred future that is also feasible and likely to happen. And I want to be remembered by people that I contribute largely to this, including everyone's opinion and not only few people's opinion. Yeah, so that's what I would like to be remembered.
Creating the unity in society, in a way, and the shared pathways forward as your service to the people.
Indeed.
Beautiful. So where can people find you if they want to get in touch?
I think LinkedIn is, you can access me and I will always reply there. Yeah.
Best place to reach you. We'll definitely put that and links to many other topics that we discussed on today's very broad but nicely structured episode, I must say. I learned a lot on the carbon side and it was nice to engage in the water side. But Momo, thanks again very much for your time and for coming onto the show and for enlightening me about a lot of these interesting aspects. And thank you again for also having me here in the Netherlands. And we definitely have to do this once a year. I guess this time is good because the weather's great.
Yeah, well, thank you for the invitation and thank you for coming all the way here. So I'm super happy we finally managed to do this podcast.
Yeah, my pleasure.
I look forward to the next one when I have much more stories to tell.
Definitely. And like I do with every guest, I always give my guest the final message. So Momo, one last message for the listeners to take away from today.
One word, resilience. That's what I want to say. We didn't cover it so much today, but I see everyone should have some resilience because climate is changing, society is changing, digitalization and AI is coming. You need resilience to all the possible changes because it will only change faster and faster and more beyond your imagination. So how do you build your own mental and physical resilience to all these changes? I think that's the thing we all need to think and pursue.
Thank you very much.
Thank you too.
And that wraps up our wide-ranging, insightful and fun episode with Wei-Shan Chen. For more information on nicknames and semiconductors, a catalog of kitchen grinders, or an overview of different natural resource cycles that you can close in your day-to-day, check out the show notes for more information over at petermbach.com/podcast. And as always, thank you listeners for tuning into this episode and for your feedback and support. If you are enjoying this show, I would be incredibly grateful if you could share this podcast with your family, friends, colleagues, and even fellow rugby players. Subscribe or follow this podcast on Spotify, Apple Music, other podcast channels, or follow the LinkedIn group to stay up to date with the latest releases. If you're curious about me or my work in general, you can also check out my website or social media. Head to petermbach.com, my YouTube channel, Peter Marcus Bach, that's Marcus with a C, or follow me on X at petermbach or Instagram at petermbach87. Feel free to reach out to me with any feedback or guest suggestions so that I can keep improving this show. The podcast's intro and outro song is called Starsky by Alex Kieran. Stay tuned for our next episode and next guest to hear how they are tackling the grand challenges.